geometry review, and this will be pages 6 and 7, or pages 7 and 8, the alphabetical matching, pages 7 and 8. Here it is on your class page. And so you can think of this as a matching type of idea. Notice that each of the choices, tangent, 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 are choice A, and the same thing with choice B would all be tetrahedrons. And you're only going to use one answer in each problem, tetrahedron. Okay. So once you choose the correct answer, you can eliminate it from the other 4 problems. Okay, so let's go through this and see how it fits together. A polyhedron that has 4 faces. Well, we know that answer is tetrahedron. We actually did that back way on page 1. So that's the correct answer there, which means we can eliminate tetrahedron from the other 4 choices. So for example, in 72, we know the answer is not tetrahedron because we've already done that. And in 73, it can't be tetrahedron. And in 74, it can't be tetrahedron, nor in 75. Okay, so that sort of eliminates some of the choices. Let's go down to 72. A statement that is proved by reasoning deductively. This is deductive geometry. From already accepted statements. Tangent, no, that's a line that touches that circle in one spot. A theorem, that sounds plausible. Transversal, that's a line, and certainly not a triangle. This is, in fact, theorem. So once again, we can go down and now eliminate from 73, theorem, don't know that. 74, don't care about that. And 75, don't care about that. Okay, do you see how this is working? 73, a polygon that has 3 sides. Well, heck, I know that one. That's a triangle. Triangle. So this cannot be triangle, nor can this be triangle. So now we're down to 74, a line in the plane that intersects a circle in exactly one point. Well, both tangents and transversals are lines. Okay, so that might be a little bit interesting. Look at 75, a line that intersects 2 or more lines that line the same plane in different points. So you might have a little bit of confusion here. I would hope not. When you're talking about circles, we reference tangents. And when you talk about transversals, that's the idea of 2 lines typically parallel and one that crosses it, hits it in 2 spots. So there's the answers to 71, 72, 73, 74, and 75. And you're actually going to be circling these on your test paper. You can circle the correct answer is what it says. So I would circle tetrahedron, theorem, triangle, tangent, and transversal. Okay, let's look at the next batch. 76 through 80. All of these are A words. Are you awake? Okay, let's see. A pair of rays, see if we can, there we go. A pair of rays that have the same endpoint. So we have acute triangle, that doesn't sound like 2 rays. The altitude of a triangle, that's not a ray either. An angle, so that's possible. The apothem of a regular polygon in area. The answer is, in fact, angle. And you might want to look at the glossary and find that. Let me pause this just for a second. Okay, so we're back. Sorry about that. A pair of rays have the same endpoint. That's a triangle. The measure of extent for plane figures. So that's sort of a strange question. Let's skip that just for a minute. Pretend we didn't know that. A perpendicular line segment from the corner of a polygon to one of its sides. Maybe we don't know that either. There's a polygon and we're going from the center to one of its sides. So what do you call that? Let's say we didn't know that one either. Maybe we can figure out perpendicular line segment from a vertex of a triangle to the opposite side. That sounds like a little bit easier. That's altitude, we know that. So let's altitude of a triangle there, which means up here we can eliminate altitude, and in this one we can eliminate altitude. Okay, back to 80. Now a triangle, all of whose angles are acute, well, duh, that's sort of an acute triangle. So now we can eliminate that from here, And from here, we've already taken care of, let's see, angles, so we can eliminate that and that. So now we're looking at 77 and 78 again. The measure of extent for plane figures, is that an apothem or is that the area? And a perpendicular line segment from the center of a polygon to one of its sides, again, an apothem or the area. And, you know, if you're unsure, you could just take a reasonable guess. A measure of extent would be area. And if you actually look at the glossary, you should probably look and see how area is defined. And perpendicular line segment, that's apothem. Okay, so there's your A words all figured out with a short discussion. Let's go to the C words. Okay, C words. Are you concentrating? Let me get rid of some of this. Okay, back to our A words. The line segment that connects 2 points on a circle. Let's see. The point in which the medians of a triangle are concurrent. We saw that one on an earlier page. The circle that contains all the vertices of a polygon, the center of the circle circumscribed about a polygon, and an angle whose vertex is the center of a circle. This one looks like it might be the easiest. The center of the circle circumscribed. Well, that would be a circumcenter. So sort of the word gives it away. The center of a circle circumscribed would be a circumcenter. Let's go through some of the other ones. An angle whose vertex is the center of a circle. Here's a sketch. Circle. What kind of angle is that? Well, we have a central angle, a centroid, a chord. In fact, this is the only one that says angle. So that sort of screams that's got to be the answer to 85. Okay, let's see. Going up to 83. The circle that contains all the vertices of the polygon. So let's suppose we had a circle and we had a polygon in here of various sizes, and we're talking about this circle that contains all the vertices. Well, don't you see that that circle is outside of the polygon? So that is a circumscribed circle about the polygon. So that would be E. Okay, 82. The point in which the medians of a triangle are concurrent. Well, that was that problem again. Remember, medians are find the midpoints and connect them to the opposite sides, and they all meet at this point of concurrency. And you should know that. That is the centroid. You can also call it the center of gravity if you want, the centroid of a triangle. And so that brings us back to the first one, and since we've got all the other ones figured out, we've already used central angle, we've already used centroid, circumcenter, and circumscribed. This has got to be chord of a circle. Okay, let's go to the I words. Center of an inscribed circle. Well, we had circumcenter, so this is the center of an inscribed circle. That should obviously be an in center. Okay, so again, the words sort of help you figure out the terminology. A polygon whose vertices lie on a circle. So this is sort of the same idea that we had in the previous one, except now we're talking about the polygon. Yes, the circle is circumscribed about the polygon, but the polygon is inscribed in the circle. So that would be E. Polyhedron with 20 faces. We saw that on the first page. That was an icosahedron, icosah. An angle whose vertex is on a circle and whose sides intersect the circle in another point. That probably should be in two other points. So let's see. An angle whose vertex is on the circle and whose sides intersect. Okay, so two other points. What kind of angle is that called? Again, notice it says angle. Only one of these has angle in it, so inscribed angle. That sort of gives that away. And the last one, number 90, a circle for which each side of the polygon is tangent to the circle. Whew. Okay, so we have a polygon, let's say a triangle, And we need a circle now that each side of the polygon is tangent to the circle. So now this circle is inside the polygon, so that is in fact an inscribed circle. By the way, it does say a circle, and this is the only choice that has circle in it, right? So it's the inscribed circle. So that's not too bad. Okay, zipping down to the words, and then we'll do the formulas real quickly. By the way, the formulas, again, all in the formulary. You should be looking in your textbook at those basic formulas. Okay, two lines that are not parallel but do not intersect. They have to be in different planes. Those are called skew lines. A line that intersects the circle in 2 points. That's called a secant. Secant. A quadrilateral, all of whose sides are equal. A quadrilateral, not a triangle. Secant is a line. Sector of a circle, it has to be a square. And by the way, typically, if you have all sides that are equal, that's a rhombus, but a square would be a rhombus that's also a rectangle. A region bounded by an arc of a circle and the 2 radii to the endpoints of the arc. A little sketch. Arc of a circle and the 2 radii to the endpoints of this part of the circle. So it's a region. That's called a sector of a circle. And the last one, triangle with no equal sides. That's a scalene triangle. Okay, formulas. Again, you can sort of think of this as matching. Once you get one figured out, you can cross it from all the others. Okay, so let's see. Circle, that's the area for a triangle. Volume, that's volume of a prism. Circumference, okay, that has to do with, there it is. This is the only one that has to do with circles. So we can cross that from here, and here, and here, and here. Okay, number 97, square. The area, that's for triangles. Volume, that's for prisms. Diagonal, the diagonal of a square is in fact the square root of 2 times the side. So we can cross those off. Okay, let's go to 98, prism. We already said that. There's the volume for a prism, so we can cross that out of here. And we get down to triangle. The area of a triangle is 1/2 base times height. We know that. So we can cross that from here. And so in a right triangle, sure enough, we're left with the hypotenuse of a right triangle is square root of a squared plus b squared. Okay, so there's your sheets 7 and 8. And I'll put a couple of other of these little videos together in the next few minutes. Should have everything up by 11 o'clock. Okie dokie.